All right, this is the second FRQ on the 2012 AB exam. Since it's FRQ2, that means we're using a calculator. So I'm going to go ahead and get these functions typed in. So I've got y equals ln x. I'm going to go ahead and write that I'm plugging that into y1. The second one is 5 minus x. That's my y2. No typos. I'm going to go ahead and fit my window. 1, 2, 3, 4, 5. So I'm going to go from 0 to 6, and then 0 to 2 maybe. There we go, so I can see everything. Now we need to know what this intersection is right here. And the thing that I see that students make mistakes on with this all the time is they make estimations for that number. And if it's calculator active, absolutely do not make estimations. It's definitely a decimal, and you're going to need that decimal to get full points. So what I'm going to do is second trace, intersect. First thing, I just want to know what that point is. Press enter, enter, enter. So we've got 3.69344414. I'm going to call that A. I'm going to call that B. The benefit of giving it a name is that now you don't have to write the decimal. You can just refer to it that way. So I'm going to get out of this and hit the X button. There's my decimal. I'm going to store that as A. Okay. So from here, we want to find the area. We have two different ways we can do that. You can do it in terms of X, or you can do it in terms of Y. The benefit of doing it in terms of Y is that you can do right minus left, and then you don't have to break it up into two different integrals, so that's kind of nice. But then you do have that decimal. You'd have to go from 0 to that decimal for your integral, and you'd have to convert these to be in terms of Y. So it's got some downfalls. The nice part about doing it in terms of X is that we already have all these X values that we want. The graph is already in terms of X, but the downfall is that we will have to break it into two integrals. So I'm expecting most of us probably did that, so that's what I'm going to do. Oh my goodness, you're fine. All right, so the first integral is going to be from 1 to A. And if we do top minus bottom, this was the first graph. So this is ln x. This is 5 minus x. So I'm going to do ln x minus 0, or just ln x. And then I'm going to add the other one. So from A to 5, right? 1, 2, 3, 4, 5. Yeah. From A to 5 of top minus bottom. So 5 minus x minus 0. All right, and then I can go ahead and just type that in. So I've got from 1 to A, and ln x was my y1. I wanted to add that. Plus, from A to 5, I'll just type in 5 minus x since I know that's easy to do without typos. All right, so that area is 2.986. Region R is the base of a solid. For the solid, each section perpendicular to the x-axis. So we're doing it in terms of x is a square. So the side of the square is top minus bottom. So it's going to be ln x minus 0, and then we're going to have the other piece, right, which is 5 minus x minus 0. And then for a square, we have side times side, so we have side squared. So if we want to find the volume of that solid, we're going to say from 1 to A of ln x squared plus A to 5, 5 minus x squared. And then because they don't want us to evaluate it, we're done with that one. They don't even have to type it in. All right, let me tell you, When you guys are doing these problems, if you start to feel like things are getting way more complicated than they should be, that's a good clue that they probably are, that you're doing something wrong. So when I was doing part C, I was like, okay, horizontal line K. Here's all my work here. I started like setting things equal to K, solving for X, so I could figure out where it would intersect and all these things. And then when I looked back at the answer key, I was like, oh, they just did it in terms of Y. That makes a lot more sense. So with FRQs, if you have a really convoluted way of doing something, odds are there's a simpler method that you're just not using. Now, I am pretty sure that I still did it correctly, but when I was doing it, I was like, there's no way this is what they were going for. So just keep that in mind. When things get really crazy, just remind yourself, yes, the graders and the people who wrote the test are a little bit evil, but they're also not insane. And grading something super crazy for everybody would be kind of an insane thing to do. So for this one, if we do it in terms of Y, then we get to do right minus left. And when we do that horizontal line that divides it, then all that horizontal line does is it changes the interval you're going to use. All right, so we'd say from like 0 to K, and then from K to that 1.306 number. All right, so I'm going to go ahead and say we have to rewrite some things here. So if I have Y equals ln x, and I want it to be in terms of Y instead of in terms of X, then I have to do E on each side. So e to the y equals x. So this curve over here is e to the y. And then for the other one, I had 5 minus x equals y. So I can subtract the y over, add the x over, I get 5 minus y equals x. Okay, so if I want to show that I can solve for some value for k where it's going to be half of the entire thing, then I've got several different ways I can write it. So I'm going to show you one and then I'll do a few different ones. So I'm going to say from 0 to k, so I'm talking about this area right here, from 0 to k, and I'm going to do right minus left. So I've got 5 minus y minus e to the y dy. All right, and that's going to equal 1/2, and you can put of 2.986, since you already used it in part A, you can go ahead and use that number. When I did it, I didn't do that, I just said the whole thing from 0 to B, and then I did right minus left. So as long as you have something like this in there. Now, there's a common wrong answer that I've seen students write, and this is what it is. The common wrong answer is to say from 0 to k of that stuff plus from k to b of that stuff. And I just want to remind you the b value is what I was calling this right up here. Okay, so if you say this area plus that area equals the whole thing, you are not wrong, that's correct. But you are not proving that k is exactly halfway between those. It could be 2/3 of the way between, and what you wrote is still technically correct. So for you to get full credit for this, you have to specifically say that this is half of the whole thing, or you could say that these two pieces are equal to each other. That should get full credit as well. So be careful about that. You're not just saying one piece plus the other piece equals the whole thing. You have to specify something that clears up that it's exactly half of that to be able to get that credit.